notice, and this is a typical copyright. We continue with the mathematics syllabus for CSEC 2018 to 2027. This is a reminder that the math syllabus is divided into 9 sections. As it relates to the examination papers, it consists of 3 papers. Paper 1, 60 multiple choice questions. Paper 2, an assortment of structured questions. And paper 3, which is SBA for school candidates, or alternative paper to the SBA. It's a written exam for private candidates. Reminder again that all papers of the exam, you will be provided a formula sheet. Secondly, silent, electronic, non-programmable calculators are permitted in papers 2 and 3 only, so none in paper 1, which leads us to one extremely important caveat, and that is you will need to know the times tables 2 to 12 if you don't know them already, if you hope to pass this exam. It is crucial that you know the multiplication tables. I am emphasizing that. This is the one that we were learning from since we were in primary school. And this is another format of that same multiplication table. 9 sections. I was hoping that by the end of September 2024, I would have all 33 videos from section 1, number theory and computation, uploaded and published on YouTube. However, I ran a little late with my schedule, but this is the final video in this section, even though it is now October, not September, October. October 11th, 2024. So all of these 33 videos are available on YouTube in their entirety. For the rest of October 2024, I hope to get the 13 to 15 videos from consumer arithmetic uploaded and published, and then 7 to 10 videos in November 2024 on sets, and 16 to 18 videos by the end of December 2024 on measurements, and then January 2025 statistics, February 2025 algebra, March 2025 relations, functions, and graphs, April 2025 geometry and trigonometry, and finally by May, mid-May 2025, vectors and matrices, and that will cover the whole syllabus as it relates to objectives. So as I already pointed out, I have divided section 1 into 33 videos, all of which will be made available on YouTube in their entirety. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. So please look at these 33 videos, make sure you know them well, and then decide if you will go on with the rest of the syllabus, because those videos will only be partially available on YouTube. To see the complete videos, you will be redirected to another site where a fee is charged. So these 16 videos, as you know, have already been completed and published, plus those other 16 there. That would make it 32. And now we are on this last video, but as I said, this video based on objective 18, most of it has already been covered in objective 14, where it also talks about ratio, proportion, and rates. So this objective specifically says to divide a quantity in a given ratio, and that is what we will be doing. Firstly, we need to explain what is a ratio and what is a proportion. A ratio is the comparison of one quantity to one or more other quantity. For example, in company X, there are 30 female and 20 male employees. So the ratio of female to males is 30 to 25, written as that, 30 with a colon, 30 to 25, and that can be reduced to 6 to 5. So for every 6 female, there are 5 male employees. A proportion is the equivalent ratios of another ratio. Example, company Y has the same ratio of female to male employees as company X. If there are 18 females in company Y, then there must be 15 males in this company. So 18 to 15 reduced will give us the same 6 to 5, which we had over here. So this ratio is in the same proportion as that. So the proportion of females to males in both companies is the same. 30 to 25 is the same as 18 to 15. Think of proportion as equivalent fractions. 30 over 25 is equal to the same as 18 over 15. But note that in this objective, we will not be dealing much with proportion. We will be dealing mainly with ratio. Still on ratio, a farmer planted crops as follows: 5 hectares of pineapples, 2.5 hectares with corn, and 10 hectares with oranges. What is the ratio of the pineapples to corn to oranges on this farm? Well, if it is 5 to 2.5 to 10, if you divide everything there by 5, you will get 1 to half to 2. But it is difficult to understand a fraction in a ratio. So if we multiply throughout by 2, we will get 2 to 1 to 4. Or alternatively, you could have divided each of these by 2.5, and you will still end up with 2 to 1 to 4. That is the ratio of pineapples to corn to oranges. A school has 350 students and 25 teachers. What is the ratio of teachers to students? Well, 25 teachers to 350 students, and you reduce that to its lowest and you get 1 to 14. But this objective requires the converse of what we just saw here in those two examples. Given the total amount, we have to divide it into a required ratio. So that is what we will be doing for the next 5 or so examples. If you find this video useful and interesting, please like and share. Like, share. And you may also consider subscribing to this channel. Subscribe. After all, it doesn't cost you anything, and it means a lot to me. So, continuing with objective 18, divide a quantity in a given ratio. Example 1. A father gave $40 to his son, Harry, and told him to share it with his younger sister, Sally, in the ratio of 5 to 3 as their school allowance for that day, Harry taking the larger share. How much does each one get? So we know the approach we will be using. You simply add the numbers in the ratio. If we add 5 and 3, we will get 8. We will use this sum as the denominator of the two fractions we are required. So 8 will be the denominators of both. We will set each part of the ratio as the numerator of each of the fractions. So one of the fractions will be 5 over 8, and the next one will be 3 over 8. We will then multiply the total by each of these fractions. So the denominator is 8. The numerator, in the case of Harry, will be 5. And if you multiply 40 by that, he gets $25. And for Sally, you multiply 40 by 3/8, and she gets $15. Or once this first part here is calculated, you just subtract it from the given total. So 40 minus 25 will give you 15. It's your choice. Either way is correct. But to go back to what you were doing, in effect, you divide the $40 in 8 parts or 8 shares, with Harry getting 5 of those shares, so that's 5 over 8, and Sally getting the other 3, which is 3 over 8. Example 2. We will assume that it is the same father. He gave his son Harry $75 this other day and told him to share it with his 2 younger sisters, Sally and Indra. So maybe Indra didn't go to school in that first example we looked at. But today, there is Harry, Sally, and Indra. And Harry is to distribute this $75 in the ratio of 5 to 4 to 3 as their school allowance for that day. Harry gets the largest share and Indra gets the smallest. How much does each child get? Express your answer correct to 2 decimal places, like dollars and cents. So we will add the numbers in the ratio, and 5 plus 4, 9, and 3 would give us 12. That 12 will function as the denominator of the 3 ratios. Each part of the ratio will act as a numerator for one of the 3 fractions. So one will be 5 over 12, next one will be 4 over 12, and the next one will be 3 over 12. You will multiply the total by each fraction. So Harry gets 75 multiplied by 5 over 12, which would be $31.25. Sally gets 75 multiplied by 4 over 12, which is $25. And Indra gets 75 multiplied by 3 over 12, which would be $18.75. Again, what you did, you divided $75 into 12 parts or 12 shares, and Harry gets 5 of those, Sally gets 4 of those, and Indra gets the remaining 3. Example 3. A standard mixture for concrete is 3 parts crushed stone, 2 parts sand, and 1 part cement. Let's say 1 bucket, 2 buckets, 3 buckets. To cast a beam, a builder needs 0.375 cubic meters of concrete. How much of each type of material is needed? And you are told to assume that 1 part stone plus 1 part sand plus 1 part cement equal 3 parts. In real life, that's not so. Actually, it is less because the stone don't fit neat to each other. There are spaces in between, and some of the sand and some of the cement go into those places. So 1 plus 1 plus 1, in this case, will be less than 3. But never mind that. We are told to assume that 1 part stone plus 1 part sand plus 1 part cement is equal to 3 parts. So how much of each will we need? Again, we simply add the numbers in the ratio, which will be 3 plus 2 plus 1, which will give us 6. We set each part of the ratio as the numerator with 6 as the denominator, and then we multiply the total by each fraction. So stone will be 0.375 multiplied by 3/6, and we get 0.187 cubic meter. Sand will be 2 2 of the 6 parts. So multiply 0.375 by 26 and we get 0.125 cubic meter. And cement will be 0.375 multiplied by 1/6 and you get 0.063 cubic meters. So in effect, we divide the total into 6 parts. Stone will be 3 of those, sand will be 2 of those, and cement 1 of those. Example 4, the perimeter of triangle ABC is 21 centimeters. If the ratio of AB to BC to AC is 3 to 5 to 4, calculate the length of each side. So as I said, we will add up all the numbers in the ratio, and 3 plus 5 is 8, plus 4 would give us 12. We will use that 12 as a denominator of the 3 fractions. Each part of the ratio will function as a numerator of each of the fraction. So 3 12s, 5 12s, and 4 12s. And then you will multiply the total by that fraction. So let's look at our triangle. Let's say that is BC, this is AB, and that is AC. AB is 3 parts, BC is 5 parts, and AC is 4 parts, so 3 to 5 to 4. We want to know the actual measurement if around this triangle is 21 centimeters. By the way, this triangle is not drawn to scale. So all the way around from A to B to C back to A is 21 centimeters. Well, we want to know the length of each side. So, as we said, 21, AB would be 21, multiplied by 3 twelfths, 3 twelfths, 3, and that will give you 5.2 centimeters, 5.2 centimeters. BC will be 21 multiplied by 5 over 12, 5, and that would give us 8.8 centimeters. And finally, AC would be 21 multiplied by 4 twelfths, and that will give us 7 exactly centimeters. If you add all of those, you will get back 21 centimeters. So in effect, you divide a total of 21 centimeters by 12 parts. AB is 3 of those parts, BC is 5 of those parts, and AC is 4 of those parts. Okay, so this is the procedure you would apply if you have a quantity and you want to divide it into a ratio of 2 or 3 parts. Your syllabus says no more than 3 parts. But now that you know this, it could be 4, 5, or 6 parts. You can easily divide it. Now, example 5 is slightly different. Now, for the physics students, you may have seen diagrams like this, and this is a diagram we have in the physics section on electricity and magnetism. It says in the circuit diagram at right, the main current at A is 2.4 amps. So here is 2.4 amps. That current goes around like this. It splits up a little like that, a little like that. It rejoins here, and it comes back here. And you still have your 2.4 amps coming out here. So the question is, calculate the current through the 20 ohm resistor when S1 is closed. So when this switch is closed, current will flow. We want to know how much current flows through this 20 ohm resistor. All right. You may think we will do it the same way. We will, but with one major difference. We will do this the same way we did for all the others, with one caveat, and that is to say, we will swap around the ratios so the smaller resistor or resistance will have the larger current, which is common sense, right? If you have less resistance, then more current will flow through it. So we follow the procedure. we simply add the ratios, 20 to 30, which is 2 to 3, which will give us 5. Give us 5. We set each part of the ratio as the numerator of these two fractions, and then we multiply the total by each fraction, applying the inverse proportion rule. So previously, we would have multiplied 2.4 by 3 over 5 for the 30. And for the 20, we would have multiplied 2.4 by 2 over 5. But no, we have an inverse ratio here, so that the larger resistance gets the smaller current and the smaller resistance gets the larger current. So this is what it looks like. Remember, the denominator is 5. But for the smaller resistance, you will have a larger current. So you take 3/5 of the current, which is 1.44 amp. And you could stop there because the question asks for the current in the 20 ohm resistor. However, I did the other part. In the 30 ohm resistor, 2.4 multiplied by 2 over 5, and that resistor will have 0.96 amp flowing through it. So in effect, you divide the total 2.4 amp into 5 parts, 2 to 3, with the 20 ohm resistor getting the larger current and the 30 ohm resistor getting the smaller share of the current. So all you needed to do was this part here. Now this one is similar to example 5 that we just did, except now we have 3 resistors. And this time the current is 1.6 amp that flows here and there. And this time it splits 3 ways: 20 ohm through the 20 ohm resistor, through the 30 ohm resistor, and through the 40 ohm resistor. Comes back over here, recombines, and you get back your 1.6 amp over this side. Okay, question is, calculate the current through the 20 ohm resistor. Now I will do all 3 just to show what can be done, but all you needed to do was a 20 ohm resistor. Remember we said we will have to switch around, we will have to swap around the ratios, as the smallest resistance will get the largest current flowing through it. So if we add 4 and 3, 7 and 2, 9, remember the ratio is 20 to 30 to 40, which is really 2 to 3 to 4. So we get 2 and 3, 5 and 4, 9. So 9 will be the denominator. The 20 ohm resistor gets a larger current. So that will be 4/9 of 1.6. And of course, the largest resistor gets the smallest current. So the 40 ohm resistor will get 2/9. And so these are the currents through the various branches. But remember, all you needed to do was this one. In effect, you divide a total of 1.6 amp into 9 parts. The 20 ohm resistor gets 4 of the 9 parts, and the 40 ohm resistor gets 2 of the 9 parts. And of course, the 30 ohm resistor gets the remaining 3 parts. Now, if you are not taking physics, you may not see this kind of question in your math class. But if you do physics, expect to see something like this. You could do it the ratio way, as I just did here, or you may be given other data that you don't have to use the ratio way in your physics class. Now, there is one more objective in this section, objective 19, and it says solve problems involving concepts in number theory and computation. And that should be problems involving ratio, rates, and proportion. But you know what? That is exactly what we have been doing all along in these 33 videos. So that brings us to the end of section 1. If you have successfully completed this first section, you have something to smile about, as this is the foundational step in this journey of passing CSEC math exam. So, smile.